Good day and welcome to another tutorial on MI Grower. Alright, today I'm going to show you a very short way to solve your chain rule equations. Chain rule differential equation. Alright, so let's take, for instance, we have a function of f of x to be 2x squared plus x. Then we get function of g of x to be x squared. Remember, we can also get a function like h of x equal to cos x. Alright, and we can also get a function like I of y. Why am I using y? Because it's with respect to y. So x here is the independent variable, that's why it's f of x. But to here, y is the independent variable, that's respect to y, that's of y. Right. So this equation, what really make it chain? When we say chain, which means putting a function into another function and asking you to solve it. When you look at these functions, this one is a normal function. It's a normal function. Same time, this one is a normal function. But when you're given a function like t to be cos xy, this one is a independent variable, and this one can also be independent variable depending on the question how it's been put. Okay, so they can ask you find dt dy, or so let's put the question one, find dt dx or dt dy. This explains that this function is a multiple function. It has x and it has y. Okay, see, normal people find a chain rule to a very complex way, so I'm going to go by a very short way to go by this one. So we are going to deal with dt dx. We don't say over, it's not a function. Dt over dx is wrong. We say dt dx because it's not a fraction. Dt dx is a differential operator. Okay, so we are going to do with respect to x. Alright, let's rewrite the function here. T is equal to cos x y. We are differentiating with respect to x. This means only x is the independent variable. If that's the case, our y becomes constant. Alright, take note, dt dx. And the equation says step 1, maintain the function in the bracket. So x, y, put in brackets, maintain it. Then differentiate the trig function. When differentiate cos minus sine, they multiply the whole bracket by, then we are going inside the bracket as a whole, we differentiate the one inside the bracket, and x is the independent variable, so y is a constant. And when differentiate xy, because x has a power of 1, it gives us 1, because the rule says multiply the power by the coefficient. The power here is 1. 1 times y is what? Y. And you subtract 1 from the x, and x has a power of what? 1. So 1 minus 1 is 0, and any number to the power 0 the same 1, so y is what? 1. That's it. So we multiply through minus y sine xy. This is our value. If you don't still get it clear here, let me explain. Y xy is equal to y. 2 x. When differentiate 2x, give you 2. When differentiate 3x, give you 3. So when differentiate yx, and the ys is the same as the xy here. So when differentiate yx, since y is a constant, give you y. When differentiate xy, y is a constant, it gives you y. Alright. Then you're going to differentiate with respect to y. With respect to y. So y is the independent variable. The same t is equal to cos x y. Alright. dt over dy is equal to, we maintain this one, xy, differentiate cos minus sine, put the whole in brackets, differentiate y. See, xy, right now our x is constant, yeah, and y is the independent variable. And when differentiate with respect to y, since x is the constant, it gives us what? X. Very simple. Okay, multiply to get minus x sine xy. Still, if you are not clear with this one, let me put it this way. And I said 2y, when differentiate with respect to y, give you 2. 3y give you 3. And the question is xy. So it give you what? X. Because the power of y is 1. When you multiply the 1 by the coefficient, give us x. When you subtract 1 from the power of y, it gives us what? It gives us 0. And y to the power 0 is 1. So, and my name is Cyborg Loftbrook. Thanks for watching.